Alright, back at it again. Number 3. I think we have all the... maybe it's just the odds. In case it's just the odds answers up there, I'm going to do number 4. 4, 6, and then 4, 6, 8, and I'll do number 9 also. So number 4, we have this cubic equation, and we want to solve it for all these times when x, what values of x will make this function or this equation equal to 0. Okay, so we go to the calculator first, type in the function, and we hit graph. Okay. If we could factor out an x, or if we could factor out any number of things, we would. If we could do factoring by grouping, we would. That would be really nice, but we can't. It doesn't factor by grouping. Okay, so we have 3 zeros here. You can see it passes through at 3 very real places. 1, 2, 3. But it looks like only one of those is going to be a whole number. 1, 2, it looks like 3. Just to make sure, we hit second. Okay, I would hit second if I could, but I can't. Okay, so I'm going to just have to go on a whim that that is 3, 0. So I think one of my zeros is occurring at x equal to 3. Okay. So how would we write that as a linear term? X minus 3. Okay. And so we want to know if x minus 3 is a factor, what is that factor multiplied by to get the original function? Okay. That's what we're concerned with when we talk about factors. Okay. We know that, for example, factors of 15. One factor of 15 is 3, but what do we multiply by 3 to get to 15? 5. Okay, so what we're looking for is that 5. It's that, what is that number we're going to multiply, or what is that polynomial we're going to multiply x minus 3 by to get all the way back to x cubed minus 9x squared plus 21x minus 9. Okay, so first step, we say, well, what do we multiply by x to get x cubed? Not x cubed, we multiply by x squared. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. And we're going to subtract that. Okay? So we'll have no more x cubes, but negative 9x squared minus negative 3x squared is negative 6x squared. And we bring down the next term. So what do we multiply by x to get to negative 6x squared? Well, we're going to need that negative 6 for sure. And then x times what is x squared? X times x. Okay, so we multiply. Negative 6x times x is negative 6x squared. And then negative 6x times negative 3, have to multiply by that one also, and you get 18x. Okay, and we're subtracting the whole thing. That's one of the most important things here, I think. If you don't put the parentheses around, you're going to end up doing 21x plus 18x, and that's not what you're supposed to do. You do 21x minus 18x, and you get 3x. Okay. For the sake of this assignment, you shouldn't have any remainders. We know it's a factor, so we know it should divide evenly. That would be just as strange as doing 3 into 15, writing 5, and then ending up with 1. And you're like, huh? No, this is bad, because this is wrong. It should be 15 and that should be 0. Okay, so just realize you shouldn't have any remainders if you know it should divide evenly. All right, so what does x multiply by to get 3x? 3. 3 times x is 3x. 3 times negative 3 is negative 9. Cool. When I subtract 3x from 3x, I get 0. When I subtract negative 9 from negative 9, I get 0. And that's my remainder, which is what I hoped it would be. Okay, so we got x minus 3 times x squared minus 6x plus 3. And that's equal to 0. Okay. If I could factor that quadratic, I would, but there are no factors of 3 that add up to negative 6. So what I'm going to do is solve it by completing the square, because that's what we've been doing most recently. So move that 3 to the other side, get negative 3. Okay, well what's negative 6 divided by 2? It's negative 3. And what's negative 3 squared? It's 9. So 9 is what I add to both sides. Okay? So I'm ready to complete the square. What are my factors of 9 that add up to negative 6? It's that negative 3 that I got. B over 2. It's always what it is. Equal to negative 3 plus 9 is just 6. Now I can take the square root of both sides, and I get x minus 3 is equal to plus or minus the square root of 6. Add 3 to both sides, 3 plus or minus the square root of 6. Okay, square root of 6 is irrational, so we just leave it b underneath the square root sign. So x equals 3, and x equals 3 plus or minus the square root of 6. Those are my 3 solutions. Then the last piece is that I want you to see this done by completing the square. No, not completing the square. By synthetic division. So if you want to do synthetic division, you have to get all those coefficients. 1, negative 9, 21, and negative 9. Well, what do we know that they should be divisible by? That x equals 3 business from earlier. So we put that inside the little box. We bring down our 1 and let the games begin. 3 times 1 is 3. We add that column, negative 6. 3 times negative 6 is negative 18. We add that column. That's 3. 3 times 3 is 9. We add that column. We get 0, and that's what we should have because that's our remainder. Okay? So it's a factor if the remainder is 0. All right? So if we have just divided an x cubed by an x, then we're going to end up with an x squared. Okay, then you just go down the line, x and then a constant. X squared minus 6x plus 3. And looky here. That's exactly what we got when we did long division, and that's how it should work. Okay? Jump down to number 6. And the first step is that we're going to go to the calculator. We're going to type that function in, and we're going to find a 0. We know because it is cubic, it's going to pass through the x-axis somewhere. We hope that point is right on a grid line, so we type it in. We hope that it's an integer, and it is. Let me see, 1, 2, 3, 4, 5. I'm going to make sure. I can just go to the table. Down, 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 down. Oh, come on. When I get to 5, hopefully I see 0. There we go. 5, 0. So x equals 5 is a 0. Hence, the y value is 0. So I can go back over here with the knowledge that x equals 5 is one of my solutions for x. Okay, now another thing, look back at the graph. Notice we only have one spot where it passes through the x-axis. Here we have this point right here is what you would see if that was a quadratic and that was the vertex, then you would be looking at non-real solutions, right? Same thing here. We have a real solution, but we also have 2 non-real, because that's the fundamental theorem of algebra. We should have 3 zeros for a cubic function. And we do. We always do. We try not to violate those fundamental theorems of the class we're in. Rule number 1. Okay, so I'm going to do long division. And I do it with the linear factor, x minus 5. Not 5, x minus 5. And how many times will it go into this? Okay, I'm going to try to do this one pretty quick. I know I've got an x squared. I'll switch to blue. Waste a little time on that. And then I have x cubed, negative 5x squared, and I subtract. And I'm going to end up with 2x squared. Bring down that negative 8x. And I'll have a plus 2x. Again, I'm subtracting. Make sure you don't just do negative 8x minus 10x. It's negative 8 minus a negative 10x, which is 2x. Bring down that last little term there. and we have a plus 2 here, and that's our remainder. Okay, so we know that we have two scenarios here, x minus 5, x squared plus 2x plus 2, and ta-da! I completed the square, and we found indeed, -1 plus or minus I would be the solutions if you complete the square or if you do quadratic formula. And that's what we expect. We expect two imaginary solutions because it only passed through the x-axis once. All right, and then last step for us, let's go ahead and do the synthetic division. Okay, for that we need all the coefficients from our original function. That one, that one, that one, and that one. Okay. We line them up next to the 0 that we found from the graph, also known as 5. Okay. Then we bring down the 1. 5 times 1 is 5. Then we add that column. 5 times 2 is 10. Then we add that column. 5 times 2 is still 10. And we add that column. And so x cubed was what we started with. If we divide out a linear term, we'll have an x squared plus 2x plus 2. And that is the same exact quadratic we ended up with when we did long division. Okay, synthetic division is very, very fast. So use it. Okay, I'm going to stop it there, and I'll do 8 on another video, and I'll probably do 9 on that same video. Stay tuned.